Hello, students. Uh, Welcome to your next lab number 6. And here now, I'm switching gears a little bit because lab 5, we were dealing with the introduction of machine learning. And we want to go a little more in depth in that because we want to apply it to other data, right? But because of the fact that semester is ending, I do want to show you another a facet of Python. And again, in a basic sense, right? The basic sense, where you can use Python to do a little bit of web scraping, right? A little bit of web scraping. And what web scraping basically is that just like we used APIs like the Twitter API to get data from Twitter, right? And just like we had some preloaded data in our sklearn that we use to do our machine learning. Well, there's tons of data out there on the web, tons in web pages. And what a lot of companies and websites, some of them allow it, some don't allow it, but a lot of analysts and companies, what they do is they literally scrape the website data constantly for more information. I'll give you an example. Okay, we're going to do it. We're going to scrape a simple website today because, again, I don't know how many of you guys know HTML, and you do need to know a certain level of HTML to do this kind of analysis. But also, I want to basically introduce you guys to to BeautifulSoup. And usually there's two packages in Python that you use to do web scraping or even what we call build bots. If you're going to build a bot, and what a bot does is a bot is a program written in Python, a Python program, that constantly is extracting data from a website or several websites, and it's doing it regularly. Okay? To do that, you're going to use a software called Scrappy, right? It's an awesome software, and you can build some cool bots with it. It's a little bit, if there was a BAP class too, I mean, that's where we would talk about Scrappy. And great intro scraping package in Python, if you're going to do a one-off or like some manual scrapes from websites to get data, is called something called BeautifulSoup. And BeautifulSoup is a package where that's the one we're going to use. But BeautifulSoup tends to be used in tandem with another package called Selenium. And what Selenium is a third-party browser, small browser, right? That you can use Python to automate for you, right? So you can basically use Python to automatically use Selenium to traverse through the web looking for things. Like instead of you doing it manually, you could use it doing Python. That's pretty cool. We won't get to that, but it's a cool thing to do. But I will introduce you guys to BeautifulSoup and how it does the scraping from HTML websites. So and after we'll do the scraping, and we won't take it all to the whole level. We'll just download and put it nice into a pandas data table. One of the reasons why I want to do this is because to do the scraping and to format the data into a pandas table requires us to use some more advanced features of pandas. And that's one of the reasons, aside from showing you guys BeautifulSoup, which is a cool package, because sometimes you guys might be doing web scraping, sometimes not. I mean, there's a lot of data out there that you might want from a website, right? But it's also about the level of Python programming. So now we're going to basically, I would say everything we've been doing, aside from the machine learning is mathematical complexities. But in terms of programming, I say we've been like more in the intro level. Now we're going to enter more of the medium level of programming. We're going to kick it, we're going to go up one more stage with these new features. And that's one of the reasons I like doing this lab. So here, right, there is a website. It's a very simple website. It's an actual website of what we call the Cherry Blossom 10-mile run. Now, what is the Cherry Blossom 10-mile run? The Cherry Blossom 10-mile run is basically a race that happens down in Washington, D.C. In fact, it should be happening. I think it already happened. Yes, I believe it already happened because I think we just missed it. So, and I don't think they had it. But it happens every year. And I don't know if any of you guys have been to the cherry blossoms down in Washington, D.C. They're very beautiful. Huge tourist draw, huge tourist draw. I believe those trees were a gift from Japan to America in its founding, and there's like so many of them. And during the season, when cherry blossoms are in season, it is quite beautiful. I mean, it's massive amount of trees that are in bloom. Flowers, white pinkish flowers, are flying everywhere. For my Indian students, it's like a Bollywood film, right, that you're running through. And they have a 10-mile marathon going through these trees. and through these floating flowers and everything, and it's an amazing, amazing run. It's so popular, right? They're so popular that it's invitation only. And there's a huge waiting demand to be able to run in this race. For this reason, right? The rule is if you run in the race, you automatically get an invite to the next year's race before anybody else does, right? And for this reason, for years, I say in some cases beyond a decade or more, people always run the race because they never want to lose their spot. Because once they lose their spot, they'll never get it back. And because of this, all right, let's just go here as I talk about this. Because let me just put cherry blossom. All right, here we go. Because of this is a real thing, guys, right? Because of this, yeah, April 11th. See, April 11th. They now moved it to 2021. Oh, how hopeful they are. Okay, so it's a real thing, and in this, right? In this, they have something called race results, and for years, they've been keeping the results of the winners and losers. Like there's two different formats, right? They have. Let me click on one. Race results right here. They divide between men and women. And boom. So this is for 2012. Sunday, April 1st, 2012. This was this race. All right, let's go. Let's look at 13. All right, whatever. This is fine, right? And here's the race, right? And this is really small. You can't see it, but if you guys are following along, let me make this bigger. Okay. You can see some guy named Alan Kiprono from Kenya. Of course, Kenya won the race, fastest pace. Second place was Lonnie Kiplagat, of course, Kenya, second place. And third place was John from Kenya, third place. I feel bad for Lonnie and John. That's going to be a long flight home. Alan, my man, it's going to feel good. He's going to be feeling really good. All right, so it's a very simple web page. In fact, it's the simplest web page you can find because for my students that are not HTML web developers or haven't done any HTML pages, HTML is basically what we call a markup language. Let me show you in a second. Right here, if I go to Developer, View Source, and here now, I have the HTML code for this page. And as you can see, for any of my students that have done extensive HTML pages, this is a hell of a simple HTML page. There's just every HTML web page starts with an HTML tag, my students, and then if I scroll all the way down, right? You can view the source of any, okay, it's going to be too long for me to go down. And everything within this HTML tag, and then there's going to be another HTML tag with a slash, basically will be the HTML page. And that's basically how your web pages work. Everything is within these tags, right? There's a whole bunch of tags, H1, P, fancy tags, you can define the tags, blah, blah, blah. All this data in this page is just between this tag called Pre, P-R-E, that's it. And then all the data is right there in a big text file. This is the reason, this is the first page we show you how to web scrape because it's so easy and straightforward to scrape. Okay, to give you an example, let's grab another page. Let me think a good page. Oh yeah, Hedgerad, all right. Oh yeah, so let's go to my blog that I'm supposed to be launching soon. I keep saying that. All right, this is my blog that I'm supposed to be launching, right, for first for investment analysts in the multifamily office space. That's one. And also a little section for my students my alumni, so they can keep chugging along with material if they want to see what these other analysts are working on or talking about. And I also like to have a section for my rankings. I still haven't got the rankings up from last year of my MIT students and my MBAs. I usually like taking the top 10 or top 20 by points and putting them up there just for bragging rights. You know what I'm saying? Bragging rights. South Indians, I heard you guys get married based on your GPAs and stuff. So hopefully this will help you with your Rich does right here. All right? That's a joke. So anyway, let's look at the source code for this. Actually, this is too simple. There's nothing here. So let me take another site that I like going on to. What website do I like going to? All right, let's go to NFL.com. Excellent. No thanks. All right. So here's for football. Now I do view. Again, develop again. Again, depending, I'm on Chrome, so this is how you do it with Chrome. Safari has their own way to get the view source, depending on which web browser you're using. I click on view source, and again, view source is HTML page. Look at this, people. That page. Now you have a lot more going on. You have an HTML tag. The head tag are tags just for the browser. Let me scroll past this. Okay. After the HTML tag, within the HTML tag, you're going to have something called the body. All right? And in the body goes all the content that you want to see. There's a lot of stuff here, right? It's kind of overwhelming. What is all this stuff? There's stuff called CSS. That's what the styles are. There's stuff called JavaScript, right? A lot functionality. And we look at all this stuff. Look at this, right? All this turns into basically that web page that we were just looking at. This is quite complicated, right? This is very complicated. A lot of it is actually JavaScript. A lot of it's actually JavaScript. And this is how it's made right here. This is how it's made. So these sites are a little more complicated to use, right? Obviously, there's a lot more involved. It actually makes a lot more sense to use Selenium along with BeautifulSoup to scrape information from this site. But of course, we're starting off with something simple. This site, very nice, right? The data I want is between these tags called pre. Real easy, very easy. Like the other sites that you guys have, websites are much more simpler, non-corporate sites. You'll look at the tags and it'll be much easier, all right? So let's get started. Let me save this file as lab6. VAP lab6. All right, let's get started. All right, I'm gonna do, okay, I'm gonna jump in with my imports. I'll import my NumPy, obviously. I'm gonna import my pandas, obviously. And now I'm gonna import something new. Two things. I'm gonna import an object called requests and another object called BeautifulSoup. All right, and I'll talk about them in a second. And now BeautifulSoup. From BS4, BeautifulSoup. What is BS4? It's the newest version, the latest version of BeautifulSoup. Hopefully it's the latest version. I don't know if there's BS5 yet. Let's go ahead and use from BS4, we will use BeautifulSoup. All right. That's fine. Oh, sorry. From import. That's fine. So I process my values. All right, and now what I'm going to do is I'm going to use that requests object to go ahead and get that data. Now, what does request object do? The request object pretty much processes the HTML. The idea is look, there's going to be JavaScript functions, CSS files, etc., etc. Let it go ahead and process that and put it into an HTML sort of format. Now, this works very well. It's fantastic. The downside is in the latest JSON enabled and more advanced JavaScript frameworks, request doesn't work as well anymore. Request works for a lot in terms of taking the data and processing it so that it's like a browser. You click on it and you're getting the actual data. Because remember, there's a lot of these functions and programs behind the scenes generating these websites. So with the latest stuff now, the more advanced stuff, request can't really handle it. And this is why I said for those more advanced sites, you would use requests in BeautifulSoup along with Selenium. Selenium would help you process those more advanced JavaScript features now. So, but for our purposes, for the purpose of the website we're looking at, this is more than enough, all right? So I'm going to call this object res equals dot get. And now within get, all right, request.get. What do I put? I put the URL of the page I'm looking at. All right, let's go her, her, right? This is the actual HTML. Yeah, I want the actual HTML page. It's right here. I'm literally just going to copy this and place it right here in quotes. All right, that's it. It's that easy. I'm now going to go ahead and, underline name request. Oops. There we go. I run that, and as you can see, that was pretty fast. It was a simple page again, so it doesn't take that much. It doesn't take that long, right? Even though there's a lot of data in it, it's a simple page. All right, so I did it. People, in that one line, something very simple, I just downloaded, let me scoot this over a little bit. I just downloaded my page. All right, if I go here, values, where's my data containers? Not showing my variable. Okay, for some reason, my res is not showing. Okay, we'll see that in a second. So it doesn't show up there. Let me type in res over here. And as you can see, it's something weird, response 200, right? Now, if I do res.content, boom. What is this? You see all bunch of text and stuff, and you see some slashes here. What is all that? That's the data coming from the website. It's all stored under res.content. And now I'm going to take that data, that requests processed, that page that requests processed, got the data, and now I'm going to pass that data into my web scraper, which is BeautifulSoup. Now see how I pass in res.content within the parameter into BeautifulSoup? That's how I'm going to pass in the data into my parser to parse the data out. Now, I do a comma, and I say LXML. What is that? That is one of the most popular algorithms for parsing in BeautifulSoup. All right, that's used along with BeautifulSoup. That was a separate web scraper along with BeautifulSoup. BeautifulSoup now incorporates it, and there's different types of processor algorithms out there. Parsing algorithms. LXML is just one of the most popular ones. So that's the one we're going to use. So I'm going to take this line right here, create a variable called soup, change my LXML, and run it. All right, now I have a soup object. And for some reason, my values aren't showing up there. But they are there. But the objects are there, right? Because they're weird kind of objects. All right, so what is soup? All right, what is soup now? Okay, soup is, for all intents and purposes, soup now is all of this. It's the web page. The web page soup, that object, has basically taken the original web page and now it resides within soup in the proper structure. It literally looks like something like this. All right, if I were to do print soup, or I just typed in soup over here, right? I don't know if that's easy to see. Let me scroll across. See how it's nicely structured like a table? You're seeing the bottom rows, obviously. I won't show you the first rows. But see how it's nicely structured? It wasn't like jumble of data when I did res.content. That was all this data with these slashes and these invisible characters, right? Here, soup now took those invisible characters and it structured itself properly within your computer, right? And there it is in all its glory. That's what we mean by parsing the web page, right? That's what we mean by structuring the web page using LXML to accurately parse the web page as a BeautifulSoup object. All right, so we have this. Now what's our next step? Okay, our next step first is to identify how we're going to go about parsing this data into a pandas table. We're going to go back to pandas tables. We're going to use pandas tables to basically we're going to use our NumPy array functions, our pandas functions, to take this HTML file basically is one text. If you want to think about it, it's like a one text file, right? We want to take this whole file and we want to convert this into a pandas table with individual columns, right? We're going to convert this into a pandas table with individual columns. You guys have dealt with this situation before at work or internships where you had a jumble of text files and you needed to analyze it. You couldn't load it into Excel, and you're like, what the hell do I do? I'm going to show you what to do, all right? This is one of the reasons why I wanted to make sure I got this lesson across, because like I said, we're going from beginner to now medium level features in pandas, all right? So here, how do we do this, right? How do we make this into columns and rows into a pandas table? Well, first things first, let's understand the object we're using, soup, the soup object, all right? The soup object itself can search for any kind of HTML tag, all right? It can search for any kind of HTML tag. Notice this function here called find, right? Soup has different properties. One of them is find, another one is find all. And what soup find the find object pretty much does, it searches for tags within the HTML space. So if I go back here to my source code, this web page right here already exists in the soup object. Within that soup object, we can say, hey, find me this tag, right? Find me this tag. And more importantly, find me all the content within this tag, right? So here, okay, so we have this soup object, and don't be alarmed, I just changed the the wording on the screen a little bit, because there's a couple of soup has obviously different functions you can use. Soup, you can call the tags directly in them, right? One of the functions you can use is called find. Another one is find underscore all, and this is the one I chose to use because in our case, this HTML page only has one PRE tag. So we could have used find, because what find does is it gets you it finds the first tag that you give it, which is PRE in this case. Well, you guys might have situations where you have multiple tags, H1 tags, HP tags, H3 tags. And again, for my MBA students that have never done HTML web programming, I apologize. I'm trying to keep the HTML lingo to a minimum. But with this one page, there's just one PRE tag. But in case there's more, let's say hypothetically there are 5 PRE tags. Well, this will get them all. This will get them all. So table.pre, soup.findAll, it's going to create a list, basically, of objects. So if I take this, it creates a list of objects. So if I take this and I run it right here, all right, we have the object table pre has been created. If I do type on it, right, it says it's a BS4 Beautiful Soup element.result set. It says result set because it's a set of data, right? Even though it's just going to have one set in it because we have just one PRE file. But hypothetically, if we had a couple PRE tags in our page, it would get the data for all PRE tags, right? And here now, over here, you can see that when I do len table underscore pre, and I run this, you can see the length is 1 because there's only one item in this. Because there's only, when I say one item, mean one set of data between the PRE tags is in it. All right, so to get that data, let me just do table underscore PRE bracket 0. All right, and as you can see, again, the last part, you see that it gives you the first set and the only set of PREs, honestly, in this page here. Notice the closing tag is there. That's the closing PRE tag we don't see. We always see the opening tag, but we don't see the closing tag. Whatever is in this opening tag with the square bracket, so basically this is the opening bracket right here, right? So whatever's between this tag and this closing tag, the slash before it is the closing tag, that's all the data that's being grabbed in the first set. Let's say hypothetically I had 3 of these combinations, 3 of these sets. Find all will grab all of them, and then the length of table underscore PRE would be 3. And then to get each set, I would literally put the the position of the number of the set I want, the 0th set, the first set, or the second set, right? In this case, there's only one, so I'm taking the 0th one. So I'm going to take the 0th one, and I'm going to add another function to it called .contents. And what .contents does is it literally gives you the content within it, right? And the content, again, could be broken down into multiple different categories or other tags within it. Here we have no other tags within it. It's just one set of content, so 0 literally gives me everything. So when I do this, you notice you get the same thing back, right? The same thing back, but now I'm not getting it back. One, that PRE tag, closing PRE tag is gone. Two, the data comes back at me, back like it did before, right? Back like it did before when I ran the RES part. But it's, again, not in a structured HTML tag. Now it's like strings with those invisible characters that structured it properly. It comes back at me like that. We want this because we want to actually break this up for our purposes to put in the pandas table now, right? Because we got the data we wanted. We wanted the data all within the PRE tags, right? There's no more HTML there. That's all pretty much text and invisible characters. Now it's time, again, it was a very simple website to scrape. Now it's time for us to play. So here, that's why here what I do is I create a new variable called table. All right, I have this new value called table. And table is also what we call a navigable string. If you do run type on table, it's something called a navigable string. What is that? It's the key word is the string. It's a souped up string. Just like the strings we've been dealing with, it's a souped up string. It's one giant string. So all the data in our content, all this data between the PRE tags has now been turned into one giant line of data with words, spaces, and invisible characters that denote returns, that denote the next line, right? So it's basically just been converted into one massive line. All right, from here, right, we can see this because we can basically grab the individual characters within that giant line. Because what is a giant string? What is a giant string? Or again, when I use the term string, I mean any kind of words or sentences. What's one giant string? It's basically an array of characters. That's all it is, right? It's an array of characters. So if I do table 0:5, I'm literally grabbing the first 4 characters. And the first 4 characters are something called /r/n space space space. What is /4/n? /4/n is the invisible character for a return in a text file. Sometimes it's /n, sometimes /4. It depends on the type of file they're using to make the return. Okay, so that's what we see, right? rn/r/n/n. Okay. Now that doesn't tell us much. Why don't we grab the first 100 characters, right? If I grab the first 100 characters, now what do I see? I see this right here, which is basically something right here, which is basically I see is this. I see this, the output. And this course coincides with this right here, our credit union cherry blossom. Already we're getting into the characters, the meat of the data, right? The headings over here, credit union, cherry blossom, right here, you can see better. 10-mile run, enter, Washington, D.C. So we have an enter, new line, and then an enter, new line, and it stopped at sun. It stopped at sun right here, right? Space, sun. So that's the first 100 characters, right? So I know I can clearly see that the /r/n is my return character. I see it, right? We just proved that. I saw it here in my output, and I compared it with my web page. So guess what? The first breakdown we're going to do is we are going to break up this giant string into different sets of strings each one representing each row in my data set. So I'm going to take the giant string right here and now break it up by the invisible characters that are returns. So I have numerous amount of strings that will each represent each row of data. All right. And how am I going to do this? Well, enter the split function. The split function is built directly into this fancy navigable string, and it's also built, as you will see later on, into NumPy and Pandas as well. All right, we're going to use it. So what does the split function do? The split function literally is going to split that string into other smaller strings based on those invisible characters. So here, if I do /rn/ let me go ahead and copy this. Table rows, table split. Oh, let me fix my quotes. All right, now I'm going to go ahead and run this. Boom, I got table rows. And up here, now in Spider, you can see table rows. You can see that's a list. Look what it is now. It's back to a normal list object, size 7,202. What does that mean? I took my giant string and broke it up into 7,202 strings. All right, 7,202 strings. Right, and each string is now stored as an object, stored as a value in my list object. Right, in my list object. In fact, if I do 0:5 on table rows, what am I calling? I'm calling the first 5 rows in the list. I'm sorry, I'm calling the first 5 items in the list. And boom, this is what you see right here. The first row, empty. The second row, I don't know if you guys can see, it's kind of small here, but if you ran that line in your computer, you'll see the second row space. I got my third line, empty space. This line, my fifth line. Corresponding it now line by line. You see that? Line by line. Each one of these is now a separate string variable, and each string variable now represents a different line in the data we just downloaded. Excellent. Excellent. All right. So it's basically, it's easier to see here. So it's basically this. This is what you're seeing. Here's the square, here's the opening bracket. There's the close bracket, just like a normal list. The first line is an empty space. The second line is this. The second item is this. Third item is this. Fourth item is empty space, and the fifth item is this. Excellent. It's basically the table rows is now a list of strings. That's basically it. It's a list of strings, right? For example, to see what we just did, here was a giant, here's a simpler example. Here's a giant sentence. The cat in the hat is fat. If I simply do x.split at the word at, what's going to happen is everywhere where it finds at, that's what happened here. Everywhere where it found this character, it will split at that character. All right, it will literally break in two at that point. So the first at we find is here. Okay, so here's my first list now. the space C. The next list is going to be from this point right after the T, this space in the H, right? Because there's the other at, and that's what you see here, space in the H. And then here, the last string is going to be space is F. It stops at the at part. Is F, right? And notice there's an extra piece there. Why is there an extra piece there? Well, because remember, split splits in two. So at this point, right, at this point, this is going to split here. And by definition, it must split something here, which is nothing. So that'll be empty. That's why. That's why we have an empty space after that at. Because it's just denoting, okay, yeah, I did split it, but after the at, there was nothing there. So that's why it denotes something empty. Okay? So that's why we'll get the same results here. Same results here in that case. All right, so let's go ahead and get back into Pandas, and guess what we're going to do? Like we talked about before with Pandas, you can create any table. You can create a table with lists, series, NumPy arrays, what have you. Matrices, a lot of flexibility there. We have a list of values, so I'm going to go ahead and create a table with those list of values, so that, and we'll call it raw. I'll call it the table WebDF. I'll call the column raw, right? And this is going to be what now? Now we've created a table with one column, just one column, where each row corresponds to that line, a different line in the data we downloaded. You see that? It's just one column, right? But you'll see it. All right, and now you see WebDF up here, 7,202 rows and one column. I click on that bad boy, space it out, make it bigger, and look at that. I got my table in there. Now look, these line items are still there, right? It's one column, so they're basically still text. They're not broken up into individual columns yet. They're not broken up into individual columns yet, but I mean, we're going to do that. All right, we're going to get to that right now. All right, so I got this, and from here we're going to start getting fancy. All right. Okay, now first things first. Okay, we need to break up the individual rows by those spaces at the character level, right? Each space, even a space, is considered a character level. So how are we going to do this, right? How are we going to go ahead and do this? Well, each table gives you a hint. In this case, right? In this case, we have something here in line 7 that's going to help us out. You see, these equals right here are pretty much denoting the text space given to each column. So here, in terms of age, egg, it really means age, it says 2 equals. That means only 2 spaces are allocated to this column, and they fit perfectly. Here, in terms of the finishing place, 1, 2, 3, 4, 5, 5 places are allocated there, right? And as you can see, each one of the columns are denoted by a space in between, right? And this is basically how we're going to be able to figure out how many characters of space is between each column, by using line 7. All right. So in this case, our line 7 equals the equal signs in line 7. They're the length, or they're the width of each column within each rows. Okay. Now I want to start off. By grabbing my grabbing that row of data so I can mess around with it. And look, it's real easy. I could just simply do, if I want, I could simply just say, all right, let me just do WebDF. What is this row? Index 7, index 7. And I can literally do web index LOC 7 raw. Right? And I can call this, what do I call it? I think here I call it dash, right? I call it dash. All right, cool. And if I type in dash down here, you can see it's just all equals. Perfect. Because as you guys remember, here's a review for you guys. When you do LOC without, when you put the index number in without any conditionals, then your data comes back as simply the value in that cell. All right. But if you do conditions, the value comes back to you as a series. Right? Remember that? Difference between the value and the series by the logics. Okay. So given that, we could have just done that. It's easy. But I want to make sure my code is more dynamic. As you saw before, there's tons of web pages out there of these result sets, these race result sets. So look, it might be line 7 in this particular web page, right? Let's say I'm looking at year 2012. Well, what if in year 2007 it's on a different line? How would I know? How am I going to know? All right, here, that's when you go ahead and we're going to make it a little more fancy. Now we're going to go ahead and we're going to use the str package str package to search the whole column for a particular value, all right, values. Now in this case, we're just going to have one row that has the equals, but what we want to do is we don't know each value is going to have this funky equals right over here. See this? We're not going to search for an exact match to that. All I want to see is, hey, is there any row out there, to make this code more dynamic, is there any row out there that has an equals? Or at least one equals character. That's what that means, contains. Contains means at least this character. So this clearly has at least one equals. It has tons of equals. So I'm using this str. Remember, we talked about this library before. The str is powerful string library within pandas. And within this library, I'm going to use one of the functions called contains for equals. This I'm passing within LOC. All right. What is this going to do? This is going to go ahead and grab me my particular value, right? It's going to grab my value, my row number, right? It's going to give me my value. Now, row number is going to give me a series back. It's going to give me a series back, right? So let's go ahead and run this. I call this row number. Row number is kind of the wrong word to use, but whatever. I'll show you what happens. I do this. You type in row number down here. And what do you get? You get this. It's the same values, but notice the subtle difference. It's kind of small to see here. But notice the subtle difference here. Here, up here, it's literally quote, end quote. Here, I have the name raw up here, and I have the number 7 index in there. Why? Because row number is what? It's not a value anymore. Row number, because look, we just did a conditional search, or we did more than a conditional search. We used one of those fancy packages to search a subset of data within the columns. And that's going to create when you get those results set back a series. Or in this case, it's saying, oh, straight up, whoa, let me do this. Sorry, let's do this. Run this. Type row number in here. Right, and again, the column part is gone because I chose just one cell. Now I'm saying, give me all the rows and the columns, just that one column. Right, and now if I type in row number right here, it says literally a series, right? I'm choosing one particular cell, but because now I'm using logic to do it, some sort of logic to do it, I am using some sort of logic here. It comes back as a series, right? And now if I want that actual value, that's basically the point I'm trying to make here. If I want that actual value at this point, right, then I would have to literally do values. Now here I get a little bit fancy. I take the row number first using the index.values. I take a longer way to do it, right? And then I put the row number directly in there and get the values I want. But so my slide, I don't need to do that. I don't need to take that step. I can literally just go here, right? Because I put raw directly in here. I can literally just do at this point, I can say, you know what? My dash is now going to be my row number bracket 0 because it's a series, right? It has one value in it. Oops. Slight error. Yes. Why did I get that error, guys? I just did row number is what? Row number is a series, and I just did bracket 0. Why did I get that error? Why did I get that error? Because what am I accessing? A series is what again, people, as a review? It's your values and your indexes. So if I want to get the values from row number, I have to literally do dot values bracket 0. And now if I were to run this, series object has no attribute value. Oh, sorry, values. I apologize. I'm losing my mind here. And now you see I get the actual values, or value in this case. I get my actual dash value. So boom, I now have the dash line in dash, right? And again, what I did in step third line, basically line 31 and line 34, line 31, 34, I took 2 steps to do what I could have done in line 29. But in those 2 steps, I now have a dynamic way right? I don't have to explicitly say I don't have to explicitly say, hey, it's in 7. My code will now find out which row those equals are in, and it'll grab it and put in this variable called dash. So now in my dash, I have that row of values, those equals, and now I need to use those equals to identify the width of each one of those columns to help me break up each row into columns. All right? So let's take it up to the next step now. Okay, from here, I have my equals. Before, each space is a sequence where the columns break. So the first column breaks at the 5th character, starting at counting as 0, of course. Now to do this, right, like I said before, what are strings? Strings are basically character arrays. I mean, they're basically an array of characters. We are going to go ahead and explicitly convert dash into a character, a list of characters, So each equal will be a separate space in a separate value in the list, and each space will be a separate value. Each blank or empty space will be a character in the list. Here's an example. Take the word Batman, right? If I pass Batman into a list function, look what happens. Batman has now become, the word Batman has now become a list where each one of the letters is now a separate value. That's what the list function can do. The list function can take a string and convert it into a list of characters. So here we have a list of characters from Batman. We're going to do the same thing with dash. Right? And we're going to kick it up a notch because we not only want to make it into a list, but we want to convert it from a list into a NumPy array, right? We want to convert it from a list into a NumPy array. So here we go. And we're going to call this DA. Okay, DA for dash array. Stands for dash array. All right, so basically I'm just doing 2 steps in one. I'm converting dash into a list, and that list is now being converting into a NumPy array. Boom. Click on DA over here. Boom. Look at that. Look at that NumPy array. Look at that. It's showing it vertically, obviously, but look at that NumPy array of all those equals. Beautiful. All right, beautiful in those spaces. So if you were to, DA, if you were to look at it vertically, horizontally, it would look like something like this. Equal, space. See, the space is a value too. That's 0, 1, 2, 3, 4, 5. The 6th value, or 5th position, is a space. Space, 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 space. All right. Now we did this, we converted it into a NumPy array because NumPy has a world, an arsenal of libraries at our disposal to get the results we want. For example, if only there was some function out there, that could tell us the position of a particular value within a NumPy array. Lo and behold, there is. It's called argwhere. All right, argwhere. See that? Argwhere. And argwhere, all you do is you basically put the NumPy array you want to search through, and you want to say basically, hey, wherever the values in NumPy array, in this particular NumPy array, equal this particular value, show me those positions. This is how you can scan a massive NumPy array for particular values, or the positions of particular values in one shot. And when we do this, you're going to, by the way, see some funky result, and I'll talk about that in a second. You guys are ready for it, though? Oh. Wrong quotes. There we go, the right quotes. Boom. You get a result back like that. Ladies and gentlemen, my intro machine learning classifier analysts. What is that? And what do we see in front of us? This shouldn't scare you. This is a 2x2 matrix. 2x2 NumPy array. It's a 2-dimensional NumPy array. See? Here, right? This is the first row. There's one column. First row of the first column, second row of the first column, third row of the first column, etc. One column, but multiple rows. It gives you the value back as a two-dimensional array. Why does it give you back the value as a two-dimensional array? Why not? All right, it just does. It just does. But we're not scared of that. You guys have messed around with three-dimensional arrays, right? Nothing's gonna scare you guys now. You guys are crazy, all right? So what do we want to do? But we want the values back as a simple list of values, right? Or a simple flat array of values, right? So how am I going to, actually I want it as a list of values, all right? And there's a reason I want it as a list of values, because there's another function I'm going to use. So how do I take this crazy two-dimensional array and convert it into a simple list? I'm going to use another function called flatten. And here I do it in one shot, right? I'll do it in three lines in my code, but here I do it in one shot. I run the argware command, I run flatten on it, and I convert it to list, right? And I create this new thing called -pos, dash positions, and it's basically a list of values. And these list of values have the positions of all the spaces. So like, for example, this is going to be 5 right here. And so that's basically saying 0, 1, 2, 3, 4, 5. So 5 has the first space. The next space is in position 17. The next position is in 24. The next position is 47, etc., etc., etc. I'll create this in, I'll take 2 steps to create this, right? Just so you guys can see both one line and the other line. So np arg anywhere, I'll call this the, I don't know, DA2 dimension, I guess. DA2D. All right. And then I'll call this DA1D, one dimension, because I'm going to just take the 2AD two-dimensional array and call the flatten function. And it's literally going to take it, just like we used the reshape. Remember the reshape function we used, guys? Right? Just like we used the reshape function to change a single array into a multidimensional array, we can take a multidimensional array and squish that bad boy into a one-dimensional array. All right? And now DA1D is an array that's smushed into one row. And you guys pretty much know the deal, right? It's basically row by row by row. It just happens that there's one value in each row, so it's pretty straightforward how that works. And from here, right, I have this NumPy array. I'm going to convert the NumPy array back into a list called -pos. Stay consistent with our slides. And I simply do a1do dot to list, and it does exactly what it says it does. It converts that NumPy array back into a list. And now I have -pos, which is a list, simple list. You see that? Simple list. Cool, huh? All right, so from here, I'm going to go ahead and now attempt to start breaking up my rows using that list of values. All right? So how do you do it? All right, here I have an example of how it's going to happen, because it's going to get a little crazy here with the data. So as long as you understand these little examples, you'll be with me. All right, if I have the text, I love dark chocolate mousse from Mara's. And yes, there's a place called Mara's. And yes, they have a dark chocolate mousse. And yes, I love it. Okay? I can break up this word, this sentence, into 3 different subarrays at position 6 and 21. Okay, how am I going to do this? Well, first, I take I love dark chocolate mousse from Mara's and I convert it into a NumPy array. That's what I do in line 2. So WWA now becomes a NumPy array of I love dark chocolate mousse. All right? So let me go ahead and show you this. Let me go ahead and show you this just so you guys have this. All right, because it's probably easier to see here. All right. So, oh, that copied nicely. So WW, I have my variable. And this, when I do list NumPy array, what is WA going to be? Look, it's going to be the array of these words and spaces. So now we have NumPy array, I space love, LOVE space DRK. And again, it's hard to see here, but if you guys have it, if you're following along with the code, right, it's easier to see there. Let me just do type here. And boom. See? This is basically the NumPy array that's being created. All right. So it's basically an NumPy array of all these letters and spaces. Now from here, watch what I'm going to do. I'm going to use another NumPy array function called split. We saw that already, guys. I'm going to call split. And now I'm splitting it at position 6 and 21. Because I'm splitting it at 2 points, guys, because I'm splitting it at 2 points, how many new arrays will I get? That's right, 3. If you split it at 1 point, if you split an array at 1 point, you get 2 arrays. If you split an array at 2 points, you get 3 arrays. If you split an array at 4 points, you get 5 arrays. You get the gist, right? It's basically 1 and whatever, 1 plus whatever your split positions are. So here, I go and I split this, and now we do WWL. WWL is going to look real funky, because WWL now, what does WWL become? I'm going to copy this so you can see this. WWL, oh, it didn't copy that first part here. All right, there we go. WWL becomes a list, see that bracket, open bracket, close bracket, it becomes a list of NumPy arrays. It's wild. All right, let me scoot this over so you can see it clearly. All right, so it literally becomes an array, a list of NumPy arrays. So the first value in this list is this NumPy array, I space love. The second item in this list is this NumPy array, space arc dark space chocolate. And the last item in this list is this array, space moose space from Mara's. That's what NP split does. This is why we made dash pos a list, because the second parameter here requires a list. The first one here comes NumPy array. The second one here is the position. Let me comment this out. There's a faster way to do this. All right. Boom. All right. That's basically the gist of how we break up these columns, right? We take each row, convert it into a NumPy array. I'm sorry, we convert it into a NumPy array of characters, and then we subdivide, and then we break up those NumPy array of characters into other NumPy arrays, and then somehow we're going to take those subsets of NumPy arrays from the list and make them into a new columns. And we're going to do that. It's going to be fun. It's going to be wild, right? Like I said, we're going from beginner to more medium level of functionality within NumPy and Pandas. All right. But how am I going to do this? Well, how am I going to, first of all, I have these different pieces, NumPy array. I have 3 NumPy arrays right now in this example. How can I rejoin those 3 different NumPy arrays into their own string of words, right? How do I do this? There's a nice funky function called .join. .join is a weird function. It's so strange. All right, this is how it works. It basically says, okay, you're going to join every item in this NumPy. Remember, WWL is a list, right? So you're going to join every item in the first value in the list WWL, which again is a NumPy array, right? Is a NumPy array. So I take this. Right? So again, if I just run the first one right here, it's literally just the first array. That's I space love, blah, blah, blah. I'm going to take this, and if I run the quote, quote, dot join function, again, it's the quote, quote, dot join function. Strange, very strange, right? What do I get? I get this, I love. I love. Why did it do this? What does this mean? It basically means join every character, and whatever you put here, it's gonna have between each character as you join it. So because we said nothing here. We just literally had quote, quote, no space in between. It just joined everything together with nothing in between. But hypothetically, let's say I put a dollar sign in between. Then it would join like this. Like that. See that? Now every character is joined by the dollar. I space, space L, space O, V, E is joined by dollar. That's basically how this function works. All right, so we obviously, when we join it, we don't want any space in between. All right, so that's the function we're going to use to bring it all together. Now, we're pretty much ready to jam, guys. Let's go ahead and do this now. And I think we have pretty much everything. We almost have everything we need to get this done. Oops. Here. All right, let's go. Now, we're gonna play. Let's play, people. All right. Okay. Now, first things first. I want to, like I said before, I want to create every one of my rows. I want to break them up into a list object and convert that list. I'm going to create it into a list of characters and convert that list of characters into a NumPy array. Oh, pray tell, how am I going to do this? All right. Enter now this concept, this functionality that I know a lot of you that you do what I call Google Python Googling. Right? Python Googling is when you try to learn Python via Google. Right? And you will see, I know you've seen the syntax, this apply lambda x nonsense. And you are like, what the hell is this? What is going on? All right, well, congratulations. We're finally going to learn this. Okay? I want to take, let's strategize here, guys, right? So I want to take my WebDF right here, and I want to go row by row, taking each line, making it into a list of characters, and then converting that list of characters into a NumPy array. Okay? And I want to do it line by line. Okay? Well, I know how to do that. I just showed you guys the example. You guys know how to do that. We just literally went through that right here, right? We would literally run the np array command, right? And then later on, we're going to run the np split command, okay? How are you going to do it row by row? Are you going to do a for loop? I will fail you if I see a for loop. You don't do a for loop. You do something called apply and lambda x. First of all, what is apply? Apply is basically a way to apply any kind of function to every row of a column. That's what apply does. Apply literally allows you to apply execute a function on every row of a column. The same function on every row of a column. It's basically like calling a for loop for every row in a particular column. That's what apply does. So then what does lambda x do? Lambda x is the same exact thing that our iterator does in a for loop. So remember when we had these for loops here? For I in x or something like that, blah, 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 and then we have some code, right? What is I? I is lambda. I is lambda. Here, I say lambda x, but I don't have to use x. That's a variable name. I could use anything I want. I can use I if I want. Same way, where I had my for loop here, I don't have to use I can use waj as a variable. That's fine. And the same thing with lambda over here. It doesn't have to be x. It could be lambda waj. It does not matter. All that matters is that keyword lambda is declaring this as our for loop iterator as we go down the row of the column in pandas table, doing some sort of transformation or some sort of mathematics. Do you see? That's what apply lambda x does. It's the for loop for a particular column, for any particular column you decide to do it. Like for example, here, I'm saying webdf.raw. We only have one column in our webdf table as of now. So to this one column we have, I want to go down the row through each cell, and I want to do some something to each value in that cell for all the cells in that column. That is what apply lambda x is doing. And this is actually gets to the heart of why I wanted to do this lab, because I didn't want you guys to end the class without going through some of these concepts right here. So here we have apply lambda x, blah, blah, blah. We're going to go ahead and do this. All right, so look what's happening. Lambda x colon. After the colon is basically all the commands you're going to do. All the commands you're going to do. Now look what's happening here. All right, I'm literally doing this. Whoops. I'm literally doing the same command here. np.ArrayList ww. But instead of putting my variable here, what am I putting? You guys should know I'm putting the x in here. Why am I putting that x in here? Because I defined it here. I said lambda x. X will represent the values of each cell in the column as we go down row by row by row. So in the first row, x will represent the cell in wet raw. So let's look at my actual table. So x will first be this empty space, then x will be this, then x will be that, x will be this space, x will be that, x will be this, x will be that. As it goes down, x keeps becoming the values in each one of these rows. And then it does this thing, and then it does this thing. It's just like a for loop. Now, let me tell you something. This, as the table gets larger, this gets faster. This is designed, just like before, when we do vector mathematics. This is designed to be more efficient and faster than a for loop. So not only is this easy, once you get the gist of it, not only is this easier because you don't have to write the for loop, but it's faster and more efficient. So here, let me copy this and run this. Right? Get rid of that. Enter the modern world. So now what am I going to do? I'm going to create a whole new column in WebDF. I'm creating a new column. And this new column will basically be what? It'll be my raw column with this transformation at the row by row or cell by cell at the cell by cell level. So I'm taking this column and I'm applying this transformation to it, and that new transformed value from cell to cell to cell will become a new cell in this new column. All right, raw A. And basically what's happening, remember x is representing the value in each cell. I'm basically taking the value of each cell, converting it into a list of characters, and converting that list of characters into a NumPy array, just like we did before. But now I'm doing it in a broader scale. I'm doing it to a whole column of data in the pandas table. I execute this. Now I click on WebDF again. Close that. And looky. How I have a massive NumPy array. See that? Massive NumPy array, guys. All right, sweet. All right, easy. Let's do our next step now. All right, now we got that out of the way. Now we want to do our split. We already have our list of where we want to split the NumPy arrays to create a list of NumPy arrays, right? And so I'm going to go ahead and do that. And again, I'm now going to do some sort of transformation on the raw A column that we just created. I'm going to use the apply lambda x function and keywords to basically do a for loop, basically go cell by cell doing these transformations. And what transformation I want to do? I want to split it, right? I want to split that NumPy array into little NumPy arrays based on these positions. And those new split NumPy arrays will go into a new column in our table called raw AL for list. Copy this. All right, that's pretty much it. We did the logic already. The only thing new here at this point you guys are seeing is this whole lambda x, apply lambda x nonsense, which again is just basically a for loop, and that x is our iterator. And boom. raw L. Look at that. Look at that. And now, as you see that square bracket right there? I mean, you guys can't see it, it's too small. But if you spread out your column, you can see this open bracket right here, denoting a list. And then within it, you can see all these different, if you can see it, you can see the arrays, open parenthesis, close parenthesis, comma. You can see all the little subarrays. You can see all the little subarrays, right? Literally, you can see all the little subarrays separated by the parenthesis column, parenthesis column. All right, so we're almost there. Now, next step is, okay, the next step is to break those NumPy arrays. This is actually, it's not break the text into lists, is to take each one of those lists, each one of those lists. Now we have in the raw AL column, I should actually left that open. In the raw AL column, we want to take each one of these individual NumPy arrays within the list and make them their own individual column. That was the whole point, right? We have now a list of NumPy arrays. We want to now take each one of these subarrays in this list and make each one of these subarrays. So basically what we want to do is each value in the list, we want it to have its own column. Each value in the list, we want it to have its own column. And we use the same positions. There's the same number of NumPy arrays in every row because we use the same positions on each row to break up the list, right? We use basically the for loop. So how do you do this? Here's a simple example. Let's say I have this list of lists, right? So I basically have Toyota black, BMW red, Ford gray, Audi white. Notice the double brackets. It's basically a two-dimensional list. I take this and I create a table called DFEXP, data frame. So now I'm going to have this table right here. The name of this table is DFXP. The first column, it has one column called first, and it has 4 values, and each one of those 4 values is a list of values, right? Easy peasy, lemon squeezy. What am I going to do? How am I going to now take each one of these items and create 2 new columns out of it? By using a very, very slick way to do this, right? A very slick way to do this, all right? And again, this is a slightly more advanced feature in Pandas data frame. I'm going to literally call pd.dataframe as if I'm creating the same code I used to create like a new data frame. I'm going to call that code again, all right? Within the parentheses, though, I'm going to call the table that has the rows or the column of lists, right? And I'm basically saying that table, the column first, the values, right? Notice I do the column dot values. Now remember, when I do table dot column, that gives me a series. Table dot column dot values now gives me the values of those series. And now when I do dot to list, what does that do? That converts it into a list. That converts it into a list. Okay? So those values are going to be converted into a list. And now that list is being set equal to this. On the left side of the equals. On the left side of the equals is now be converted into, I'm doing bracket, bracket, and I'm doing 2 brackets inside. Basically, it's like I'm selecting 2 columns, right? And basically, these 2 columns I'm selecting, they don't exist. Second and third, they don't exist. What's going to happen? The values, right? That's basically I took the values and I converted it into a list. It's been converted into some sort of list. Those values are now going to be sent, broken up using this command, and sent to each one of these columns, the second and third column. So that when you're done, your table, now after you run this line of code, will now have the original first column, now the second column, and now this new third column. Do you see that? All right, let's quickly do this. Just so you can see this, I will copy and paste this. All right. Do boom, boom. Alrighty. All right, so I have this table called DFXP. Very simple table. Has these two lists right in there. All right, now I'm going to take this code. Let's break down what's happening here. All right, so here, let's just show you what these values, what is this? What is this going to give me? All right, as you can see, it creates a two-dimensional array. It creates literally a two-dimensional array, right? It literally creates this, the XPL up here. And what happens is, when you pass in this two-dimensional array into the data frame object, let me run this now. When you pass a two-dimensional array into the data frame object, it literally creates a table. I don't know if you guys can see. Let me copy and paste this. That two-dimensional array gets converted into a pandas data frame. With, again, you didn't give any column names, but like I said before, a two-dimensional array, this is a two-dimensional list. A two-dimensional list can be passed into a data frame, and that can be converted into a table. It just so happens, what happens is the first values of each of the rows become the first column, and the second values of each particular list or row become the second column. And they, by default, look at the column names it gives. It gives 0 and 1. You're going to see this later on. When you don't give a column name, just like when you don't give an index, Pandas will make it for you. And just like the indexes, the column names will start with the number 0 and go onward. That is the name of the column. Those numbers are the name of the column. So basically, this table, this subset table, is being passed into these two columns. So this is a two-column table, and this two-column table is being passed into these two columns in the existing table, and that is how we get, all right, that is how we get these values right here, And that's how you break out those NumPy arrays into a separate column. All right. Now, I have in my notes, what I do in my notes is, all right, what I do in my notes is I basically say, okay, look, we can apply this logic and we can create these additional columns. Fantastic. We have a slight problem here, right? The slight problem is that we're not certain that every year will have the same amount of columns, right? And we are also, we're not certain about how many columns there's gonna be, and we're not sure what name our columns are given, right? There's uncertainty. We addressed both of these concerns in the example I just did, right? It'll be done automatically for us, and we don't need to give it a column name. It'll give the number for us. Especially if we create it into a separate table, right? So one example here, this is kind of a, if you want to do it this way, you can do it this way, that's fine, but we don't have to do it this way. So we have this example right here. If you look from before, I have the I love dark chocolate mousse. We split it, and we have a list of two different NumPy arrays, right? We have a list of two different NumPy arrays. Okay? Now, from here, all right, again, so like I said before, if we split by two spaces, we get three vectors. Given this logic, space plus 1 is how many columns we need, right? And you can basically say, hey, the new columns I need are basically going to be, and now here I do a little bit of math. I say, look, the length of the dash positions, how many items there were, dash positions items there were, right? The length of them plus 1, the range, right? So it's going to give you like 9 values. It's going to give you like a list value of 0 to 9. And we can basically say, hey, my new columns are going to be basically 0 to 9. The logic here is basically doing the same logic here, because here, when I created a new table, I literally said second and third, right? So I'm doing the same logic here, except I'm trying to explicitly say 0 to 9, right, to create this and to create my new function. So because I want to keep it dynamic, but I don't necessarily need to do that if I don't want to, because what I can do is, to keep my life a little bit simpler and saner, I can go ahead and say, you know what, I have the data I need. I'm just going to create a whole new table. I'm going to create a whole new table, and I'll create this table called WebDF2. So rather than storing these values in the same table, so here I'm going to take a slight turn from my slides. Rather than putting these new tables I create in a new table, I'm going to create a whole new table called WebDF2, so I don't have to worry about the column names. I'll let that dynamically just happen. All right. So here, I'm going to call the same thing as before, pd.dataframe. I'm going to call it on the column that I want to break up. I'm going to call values on it. I'm going to call toList to create a two-dimensional list. All right, and that two-dimensional list will become a table. The only difference here is I'm literally explicitly saying, you know what, create the explicit the same, whatever index WebDF had, keep it. Again, I don't need to do that because it'll create it for me dynamically. All right, so let's go ahead and do this. I'm going to take a slide from here. You guys can you can juxtapose what I'm doing in my code with the slides. Basically the same thing. I'm just taking a slightly easier route here, guys, for you. So rather than create the new columns within the existing table, I'm just going to create a whole new table altogether. And you know what? I don't need to explicitly state the index as well, because it'll create the index. I'll go here, call WebDF2, run this, and now I have a new table called WebDF2, guys. It's opening, there it opened. All right, and now what you see is, right, I have the indexes are there, my columns are there, 0 through 9. Notice they're all numbers. This is very important if you use the lock function, because now the column name will literally be a number. So you'll have an index, your index position will be a number, and your column name will be a number, because the column name is literally a number. Okay? And it's all here. It's all here in this new WebDF2 table. And it just makes it slightly easier for me, right? Oop. All right. Now, from here, if you look at, oh, please tell me I didn't close, yes, I didn't close it. Yeah, I closed it. Let me open it again, WebDF2. All right. Okay, so I have these. Now, look, this is good, except for the fact, now, here line 7 again is my equals. I don't need that anymore. Above, I need line 6. Line 6 has my column names, the names of the column. And above line 6, I don't need any of that. That's basically the explanation of what the table is. But line 6 is my columns. Line 8 and down is my data. And line 7 is the equals. I don't need that. So basically out of this table, guys, I want to create another table with just the rows I need. Just the rows I need. Right? And that's basically what we're talking about here. Now, I want to create a new table where we select just the 6th row, the 8th row, all the way down. Right? The easiest way to do this is to create a vector, right? One, I can create a vector, or, right, and I can pass that vector directly in to my WebDF2 table and say, hey, I just want these rows. It's like basically doing this, guys. It's basically doing this, right? So if I wanted WebDF2 bracket 0, this gives me, oh, let's do something more relevant, 6, right? This gives me WebDF2 literally gives me the 6th column because I put a number in there, right? Put a number in there, right? If I do here, if I now simply say gave me all the rows. Sorry. No, sorry. This should give me the. Hold on 1 second. We'll df2 6. All right. Missing my .loc. Let's do .loc. All right. Stick .loc in there. Boom. Now, .loc, if I put 6 in there, what is it giving me? It looks like it's giving me the place division. Okay, excellent. It's giving me the 6th row. All right, the 6th row of the columns. And an easier way to see this is if I do 7. 7 has the equals. It's giving me all the equals. Remember, when you just select one line from a data frame, a pandas data frame, it gives it the value back as a series. So let's select 2 lines. Let's select line 6, comma 8. All right. Now, what am I getting? See, now what I'm getting is that we're getting to what I want. I want the 6th row. I want the 6th row and the 8th row going all the way down. I want the 6th row and the 8th row going all the way down. Right? So, how do I do this? Right? How do I do this? And I want it to be dynamic. Again, I want it to be dynamic. So here I have the 2 values again that I want. Boom. All right. I can store these 2 values in another variable. In other words, let's say something called, let's call it BB. BB equals 6, 8. Sorry. 6, 8. I showed you guys this before. This was actually from our first lab, believe it or not. Right. And if I just stick BB in here, it's going to do the same thing. It's going to basically do that bracket comma slicing that I'm doing. Right? It's basically going to do that bracket comma. Sorry, let me put this above here. It's causing an error for this. All right. It's basically doing the bracket comma slicing I'm doing. So basically now what do I need to do? I need to basically create a vector that's going to be 6, 8, 6, 8, and then all the subsequent values after 8 all the way to how many rows I have. Well, how many rows do I have in WebDF2? I know this, right? How many values do I have? I have, let's call it RC WebDF2 dot shape. I run this again. I'm using the tuple method, and R now has the value. I didn't need to do parentheses. I could have just done like this. So let me take that out. So R has the value, right? Remember the tuple feature? 72002. That's how many rows I have, and that's how many columns I have. 10. All right. We know that Python's -1, R -1. So basically, what I need to do is I need to basically get the range, right? A list range from 8 to 7,202, which is well 7,201, but I'm just going to place the range value 7,202 there, and then concatenate it with a list 6. So I'm going to basically do this. I'm going to do, you know what? I'm going to do boom plus. Remember, a list plus a list does what? It concatenates, right? Range from what? Range from 8 to what? To R. I run this. It'll give me an error because range is not a list object. Remember? Range is not, if I do this, I get a weird range object. To convert this into a list, I have to pass this into the list function. And now when I run this, BB is now going to be the rows that I want to select. And if I stick BB in here, which it's there actually, I'll get all the rows that I want, right? It starts with the 6th row and jumps all the way down to, skips the 7th, goes to the 8th row, and goes all the way down. So I just basically have now the column names, and now the values. I have the column names and the values, right? So I can easily do this, and I'm done. The problem is, again, I want to be dynamic, right? I want to be dynamic. I want to be dynamic. So this is where, right? This is where if we had the row number from before, which we don't, right? If we had the row number from before, which we don't, we basically want a way to find out, have a row number that's dictating what equals is, and basically we want another way to figure out what is the value, what is basically the, once I figure out what the row number of equals is, then I can dynamically say, okay, the sixth value, or the columns is going to be the row before it, and my list of data is going to be the rows after it, right? The rows after it. So basically, how am I going to figure out what row equals is in? Well, if we go back in our slides, it's very simple. This is why, and I went over this pretty fast. This is why we're going to call the index.value0. That is going to give me the row number of where this thing equals right here. All right. So we're going to do basically the original search we did from before. Original search we did from before. All right, let me do that here. Okay, this is all fine. But this time I'm saying, look, I don't want the values from this search. I want the index, right? And remember, when we do index, it's going to give you a weird index object. When you do values of that index object, then it'll give you actual value, right? And I'll call this RN for, or instead of row number, because I have something already to call the row number, I'll call this dash num for dash number. I run this, and what is dash number going to be? It's going to be 7. Now again, the reason we're doing this is because in the other pages, hypothetically, we would scrape, we don't know which row those equals will be on. It could be on the 7th row, 5th row, 10th row, 12th row. For any of you guys that have scraped any kind of data, you know what I'm talking about. The web pages, they're a mess. Or even if you're fixing up text files, they're never usually where their data is never where it's supposed to be. It's never formatted the right way. There's always some format is changing from time to time when you're trying to do any kind of automation. All right, so here dash number is 7. Cool, excellent. So I want to basically recreate what I did up here now. Let me just copy and paste this. All right, now it's dynamic. This part I can keep because this is pretty dynamic. Any table I get, it'll give me the rows and columns. Excellent. This part right here, anywhere where I hard-coded a number, I want to change that. So this 6 now is going to be dash num -1. Remember, 7 is where the equals are, so right before it is going to be the column names, and right after it is going to be where my data starts, +1. And that's basically what's happening in the slide. That's basically what I'm doing in this slide, where I'm dynamically identifying the rows, number 6 and 8 all the way down, not just in this particular web scraping page, but any web scraping page. It's now dynamic. It makes my life easier. So again, now I will now rerun BB, and now I have the correct rows I want, and now it's dynamic. And let's store it somewhere. Let's see what I stored it here. I called this all, I put it in WebDF2. Oh, you know what? Let me call, let me call this, I'll call this WebDF2B, right? Because I don't want to call it WebDF3. I want to try to keep it as much in sync with these slides. So I'll call this new table WebDF2B. All right, so I'll say, hey, WebDF2B equals this. All right, and now, all right, I'm excited. WebDF2B right here. Click on that. It's opening, it's opening, it's opening. Boom. All right. It's basically what we did at WebDF. It took a little time to do it, but we basically now dynamically got the column row and all the data rows and got rid of everything else we did. It took us a little bit longer because, again, we wanted to make it dynamic. We wanted to make it dynamic. Dynamic is the name of the game. For any of you guys, again, have dealt with data of all kinds, you know what I'm talking about. right? You don't want to hard code things, they break. All right, you want to make your life as easy as possible. Now, from here, right, from here, we're now going to, like we did before, I showed you guys that join command. We're going to get rid of all these numpy arrays now. Let's get rid of these numpy arrays. Let's deal with some words, people. Let's get rid of these numpy arrays and let's deal with words. All right, so what words do I want to deal with? Let's find out. So here, I'm going to create, and here is where I create a new table altogether, right? Because what's happening here is I want to create the join command on each column. Well, how do I do the join command on each column? We do apply lambda, x, r, whatever, and we do, the quote dot join r. Done. Done. And I could do that each column. In fact, I have to do it to every column. All right? But I have to do it to every cell in every column. What if I had hypothetically 100 columns? Am I going to do it to 100 columns? I could write 100 lines and do apply to each column. But again, Pandas has a function that now allows you to run a function command, like a for loop, not just on every row in a column, but in every cell, in every row, for every column. Okay? There's a function now called, like you see, for example, here, I want to apply, I'm going to do the apply join to all these guys here, to these guys, and to these guys, to these guys. I don't want to do it column by column anymore. I want to do it to every cell in the table. Every cell in the table, I want to apply this transformation. Enter the apply map function. The apply map function works exactly like apply, and it works exactly like lambda with it. But this time, instead of specifying a certain column that I want to do a for loop through, applying that transformation, I am now applying it to every cell in the table. I'm applying it to every cell in that table. This is the difference. This is the difference, okay? So here, I'm going to do copy this, right? And that transformation, I'm going to save it in the table called webdf3, right? Just creating table upon table here, guys. By the way, as you create these tables, you can delete them if you have memory issues. I know that memory issues is always a thing with your computers. I'm sorry, I'm not telling you that, but you can go ahead and delete your previous tables as you do it. Remember, del, right? Del deletes that data container. So if you need to, as you create new tables and you need to delete them, by all means, delete them if you have memory issues. I know some of you guys, your computers crash when you have too much table, too much data. All right, like even for the machine learning thing, some of you guys, your computers are crashing. So here, let me change the quotes of WebDF3, run it, it's done. I have a WebDF3 table, 7,202 rows, 10 columns, just like before. Oh, I did it to the wrong one. I apologize. Let me redo that. I want to do the WebDF2B. Remember, I have an additional table. And do that again. Excellent. Now look at this. Yeah. What do we do, people? We took a blank, basically like a text file from a web page, and we now broke it up into its individual columns. Look at that. All right. This 9th column is totally empty. We don't need it. We can drop that. Okay. But what we do want to deal with is the fact that our column is still like a row. We want to get rid of that. We want to make it a separate column name. So how are we going to do that? Very easy. All right. All right. So we did this, the apply map. It joined everything. We have all the arrays are gone. They're now words. And now we want to do 4 things, right, for our final table. We want to get rid of the excess white spaces. If you notice, God, I keep closing it. A lot of white space, guys. A lot of white space around everywhere, right? First of all, these are all characters. That's number 1. But there's a lot of white space around here, right? So we want to address this. We want to address this. Okay. So first things first. The first thing we're going to do is we're going to get rid of the excess spaces. That's easy. there's a function called strip that does exactly that. It strips the text of white spaces before and after it. And again, we're going to use the apply map to do it. We use apply map to do it, and we're just going to overwrite our existing table. Oh, that's why I closed it. Right here. All right, click on WebDF3 now. Ooh, doesn't that look better? The white spaces are gone now. See that? All the white spaces are gone. All right, now what do we want to do? Now we're going to create yet another table called data.df, and finally we're getting to our final table. That is simply going to be the second row onward. It's going to be the second row onward, okay? Why are we doing this? Because we want to actually make our first row the actual column names. That's why. So I do this. Notice I'm using ilock. And now I have a data.df table that I just created. See that? The column names are gone. They're going to be now overwritten up here, guys. How do we write new columns? Data.df columns, right? And now I go to WebDF. I simply say ilock 0 to list. Remember, columns takes a list of names, right? Columns takes a list of names. So I'm dynamically just creating that list right here using the first row of my WebDF3 table to list. Click on data.df again. And look at that. Look at that, people. Right? Look at that. Nice. All right, what else we want to do? We want to reset the indexes. How do we reset the index? Well, we know how to reset the index. We always reset the index using reset index. But now I'm going to introduce a new parameter called drop equals true. Okay, now why do I introduce this parameter called drop equals true? Because if you remember, what does reset underscore index do? Reset underscore index takes the existing index and creates a whole new column out of this. I don't want, open this right here. I don't want this index of values to be created as a new column in my table because it's meaningless to me. It's not data, right? So when the new index is created, the existing index that already exists, I want it to be dropped. That's what drop equals true does. It drops that existing index. It doesn't now append it as a new column value. It doesn't make a new column out of it. It just simply drops it, right? So here we go. I go ahead and run it. Click on data.df, and look now what happens. I got my column names. Oh, I got my indexes. Look how pretty that is, right? And now I got this empty column here. I don't even know what to do with it. That's not even called anything, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the ninth column. All right, it's the ninth column. It has like, so let's do, right? Here we stopped here, but let's get rid of our ninth column. This I don't have on my slides, but go ahead, let's go get rid of it. All right, we're going to use the deal command. First of all, let's identify it. If I put 9 in here, let's see if it gives me my ninth column. And it will not. I have to use my ilock 9. ilock 9 is giving me the ninth. Oh, it's the ninth row. I'm sorry. Sorry. All the rows, ninth column. There we go. This is what I want. All right, all the rows, ninth column. So I basically want to delete all the rows in the ninth column. Oh, didn't allow me to do that. Hold on. I think I have to literally give the column name to do this. So I have to literally give the column name. We can specify what the column name. We know the column name as nothing. It's actually blank, which is crazy. I don't know why they allow you to do this. You won't be able to delete using lock. You have to literally just call the column name. But let's verify that that's the column name. Yes, it is. It gives me those values that are pretty much empty. So now to delete this, I'm just going to directly call that column data df, right? Here's the column name. I delete it, and now as you can see, it's finally gone. I'm going to go ahead and just comment that out because I don't want to delete anything else. To delete, having those delete commands around could mess you up. So now I go to data df, and look how pretty that is, guys. Look how pretty that is. Okay. All right. All right. One more thing. I didn't have this on the slide, but one more thing, real quick. We have the places, we have the numbers, and the ages. We'll leave the 5 mile time and pace aside because that's a little more complicated. We have to convert that into actually what units you want to convert that into, et cetera, et cetera. But these right here, guys, these 3 columns, they should be numbers. Like if we do str on data df, right, you can clearly, oh, sorry. Using the wrong function here, guys. No, sorry. I apologize. I'm in R mode. So let's use info right here. And you can see that over here, it's hard to see, but those columns, everything is what we call an object. And remember, in Pandas, anything that's considered an object is considered a string. So let's convert at least those columns to to integers, all right? And to do that, it's very simple. All right, to do that, it's very simple. I'm going to basically take the, oops, right here is what I'm looking for. The place column, I want to convert it to an integer, right? And it's a very simple function that does it, guys. It's called asType, right? And you can do it on the whole column. So if I simply just do data df, I think the first one's place, equals data df place dot asType, and I want this to be now become an integer. Oh, looks like it's not allowing me to do it as an integer. Because, oh, place might have actually non-integer values. Let's go ahead and do it with, if I scroll down, it might be values that might be too big of an integer. Let's do to the age. Let's do it to age. Age is probably something that's more, the numbers won't be too large. So age, which is actually ag, that's a typo. All right, go ahead and run this. It looks like I have a value there that is not integer. It looks like I have values that are denoted by exponentials, right? Exponentials in my data, which is interesting in my data df, right? So there's ways to deal in ABI. I taught you guys that there's tricks to deal with this, right? Here, let's first. It looks like quickly eyeballing. It looks like there's spaces that's causing our problem. Like we have null values, right? And actually, we have an additional row here that I didn't even notice, 7,193. So first things first, let's get rid of our empty row here. I didn't even think about we had an empty row, so let's go ahead and get rid of that. Okay, let's go ahead and get rid of that. We want to get rid of the last row. So first I'm going to do is we'll make data df equal into data df from the first row all the way to, but not including the last row. So now data df, I go to data df now. Remember my trick, guys? I did this. I showed you guys this for using the -1 trick. Now, if I actually, easier way to do this, just do data df. I want it from actually, I have a tail function. I believe we have a tail function, right? Yep. And as you can see, we got rid of that empty row. All right. Now, another problem we have in age is we have an empty column, empty column. How do we deal with the empty columns again, guys? Data df, right? You guys remember? How do we do it? We have a function that does this for us. Data df ag. Remember the function? Dot is null. Right? That's going to give us basically all the falses and trues. It's going to basically show us everything where everything's null. If I pass this back into data df, right, it gives me the value where ag is null. And it looks like it's not empty. Oh, you know what? Because it's not null. It's giving back no values because it's not null. It's actually just probably an empty space. Interesting. Scroll all the way down. So right here, oh wait, this is the old one. So here, ag, this right here is something, right? First of all, what's good about it is that it's not a null, because if it's a null in pandas tables, what is it going to be? It's going to be a NaN. So clearly it's not a null, right? But we have nevertheless an empty space. And how do we find this empty space? Well, again, this is not in the slides, but we can use a little trick. Actually, I just remembered we just stripped our white spaces, so that's actually just an empty. Gosh, this is so annoying. It's not a null, right? It's not a null, and at the same time, it's not a. It's a text, but it's an empty text. It's very annoying. So ag equals quote quote. All right. Now if I run this, now over here you see we identified a nice row, that row, and that's really annoying. This goes under data wrangling, right? So what do we do? What are we going to name it? Well, I'm going to go ahead and just stick a value in there just for, because this is not really the point, right? I just want to show you guys how to convert the column over. And so I will just give it a value. I'll give it a value. I assume the guy is 30 years old. Why not? Right? Oops, oops, oops. I got an error because I tried to change this by using LOC. There we go. Now this will work. Very good. Okay, so now, ladies and gentlemen, I could finally, what I wanted to show you is apply the as type function to change that column into a string, from a string to a number. AG equals data df AG dot as type. And we're going to convert this into an integer. And yes, it finally worked. Click on data df. And what do you see? It's a different color. Why is it a different color? Because now it's numbers. What do these colors represent? Just like when we were doing our machine learning, we were doing a machine learning analysis. Spider automatically assigns color maps to any numeric columns so that the background color can basically stand out at you something that's extreme from the other range of numbers. Like, for instance, here's a 55, right? So that's a purple, and it's standing out at me, boom, standing out at me. And here's something like a deep red. Here's a 16-year-old, right? There's a 63-year-old, right? So you can see the range of colors, you can see the range of numbers. Bam, it pops out at you like that. It pops out, it pops out, it pops out, boom, like this, right? It pops out like that. So that's basically what I'm going to show you. So at this point now, we're pretty much done with this lab number 5. And there, we can end it right here. So there's a practice set associated with this, and I'll post that up for you guys. The video already is kind of long. I guess I do have room to do some more video. So I'll post up the practice set, and I'll start recording a video just for the practice set and post that up as well. All right. Hope you guys enjoyed the video. Hope you guys got a little something out of basic web scraping, but more out of that, the power of pandas to convert and break up these text files into nice tables that we can do some sort of analysis, storage, or analysis with. All right. Have a good day, guys. All right. Bye-bye.